When we're looking at quadratics, we're looking at a lot of different things. So here what we're doing is we're going to look at quadratics using vertex form. Okay, so now remembering when we're looking at vertex form from our formula, which is here, we have a times x minus h squared plus k. We know that h and k are going to give us our vertex. And we can kind of use any other point on the graph to find out our a value. If we just sub in all of the values, we can find a just by solving for it after. We're going to have a y value, we'll have an x and an h and a k, and we can sub them all in. After that, we can just go back and rewrite our equation with all of the values that we found. So if I look at this, it says write the equation of the parabola in vertex form. Okay, so I know my vertex is right here. So that's going to be at 2 and -1. So then that tells me that my h value is equal to 2, my k value is equal to -1, and we can choose any other point on the graph to solve for everything else. Now, when we're giving you these, you're going to have a point that kind of falls perfectly like that or perfectly like this. It's going to give us all of the information we need. So I'm going to use 0 and -9 as my point. That's not 10, that's a bracket, 0, -9. So what I would do is I would start with y equals ax minus h squared plus k. I'm going to sub in all of my values. I know my y value is -9. I'm looking for a. I know my x value is 0 minus 2 squared plus, and it's going to be actually minus 1 here. It'd be plus -1. So then we get -9 equals 4a minus 1. So that's going to be -8 equals 4a, and a equals -2. Okay, we're just using reverse BEDMAS to solve there. Therefore, our formula is going to be y equals, we've got our a value, -2. We're always going to have x, and then we're always going to have a squared here. Our h is -2, so -2, and our k is -1. And there's our equation. All right. If we're looking at something like this, so it says write the equation. So now rather than giving you the graph, we've given you the a value here, which that's also, if it says same shape, that's the same as saying congruent to. And we've given you your h and k here. So we're going to have, for this, y equals the same a value as this graph, same shape. It opens down, tells me that it's negative. I've got a negative, I've got 1 as my a value, and then I'm going to do x. And in this case, I'm going to show you it'd be x minus 0 squared plus 9. Now that doesn't really look all that great, but I can always fix that to -x squared plus 9. This is going to be one of the graphs that we do later in this unit that a lot of people are going to struggle graphing. When you look at that, that just says it's a quadratic graph facing down, and we've moved it up 9 points. Okay, we're going to let you do this question here, and we'll take it up for the warm-up tomorrow. So you can try that question on your own, and we will take it up in class for the warm-up. Looking at this here, so we've got Jack and Jill. They're standing 2,000 meters apart. So if I was doing this, and then at the end of a suspension bridge, large cables are attached 80 meters to the top of the road. The road is suspended from a large cable by vertical cables, which measure 3 meters. Write an equation in vertex form. So if we were to look at this, we've got kind of a point like this. We've got the top of 2 towers. So this is going to be 80, and we're going to be right here, and then one way over here. Okay. The tops of 2 towers, 80 meters above. We know that this is also 2,000 meters because it says they're 2,000 meters apart. The biggest part about this is just going to be making the proper diagram. The road is suspended by large cables from large cables by small vertical cables, which measure 3 meters at the center of the bridge. Okay, so what's happening here is we've got this shape and we'll call this the center. And I know the center is going to be 1,000. My diagram's pretty terrible here. And I know I'm going to have a point right there, and we've got a cable. Well, that point is at 3 meters. Okay, it says it's 3 meters up at the center of the bridge. So this diagram is kind of showing me everything I need to know to create an equation. Okay, so we've got our vertex right there, and we actually can find our A value by using this point or this point. So our vertex is going to be y equals, and I'll just write it in vertex form. We have x minus 1,000, that's the halfway point, and then plus 3 because that's where the parabola starts. Okay, it's in the center of the bridge, and those cables are going up 3 meters. Okay, that's how they're creating tension in that wire that's holding the bridge together. So now, all I have to do is choose either 0 and 80 or 2,080, and then sub in my points to get my value. So either one of those points would work, and it's not going to actually have any effect on your final answer for A. So what I'm going to do is I'm going to choose 0 and 80 just because 0 is easier to work with. So I would have 80 equals A, and then 0 minus 1,000 squared plus 3. Now, if you look at this graph, it's actually only going up 80, and we're moving over 1,000 points. So the A value should be extremely small. So when I do this, I'm going to get 77 equals A times, now we're doing 1,000 squared, so we're going to have 6 zeros, or a million. And now we're going to get A equals 77 over 1 million. And then finally, I'm going to put it into vertex form, and I'm just going to leave that fraction. I just think it's easier to deal with than making it a decimal. So I would get, therefore, my equation is going to be y equals 77 over 1 million, x minus 1,000 squared plus, plus 3. Okay, again, we're going to let you try this